Welcome to The Explainer. Today, we're going to crack the code on a tiny little detail that can literally make or break your entire data project. We're talking about type conversion. It sounds super technical, I know, but trust me, it's the secret key to unlocking what your data can really do.
Okay, so let's just dive right in with a situation I'm sure you've run into. You've got this beautiful data set, right? A whole column that looks like it's full of numbers. You feed it into your machine learning model, feeling pretty good about it, and boom, error. It just fails. It is so frustrating. But the reason why is actually pretty simple.
And this is it. This is the whole problem. Your computer is incredibly literal. So while you and I see the number 25, the model might just be seeing the text characters 2 and 5 sitting next to each other. And you just can't do math with text. The model has no clue how to find an average or spot a trend when all it sees is a bunch of words.
So this is where a really fundamental process called type conversion comes in to save the day. Honestly, think of it as the hero of our data story. It's the crucial step that closes the gap between how we as humans see data and how a machine needs to see it.
At its core, type conversion is just changing a variable's format. That's it. You're basically telling the program, hey, see this thing that looks like text? I need you to treat it like a number. Or, the other way around. It's what turns raw, messy, unusable data into something you can actually work with.
Now what's cool is that Python is pretty smart, and it gives us two main ways to handle this. You've got an automatic path, where Python kind of tries to figure things out for you, and then you've got a manual path, where you take the wheel and tell it exactly what needs to happen.
This really gets to the heart of it. On the left, you have implicit conversion. Think of this as Python's safety net. It sees a potential problem and automatically makes a change to prevent you from losing data. On the right is explicit conversion. That's your toolkit. That's when you, the programmer, step in and make a deliberate choice.
And here is a perfect example of that automatic implicit conversion. Let's say you add an integer, like 5, to a floating point number, like 2.0. Python knows that if it makes the answer an integer, you'll lose that decimal information. So it automatically promotes the 5 to a float before it does the math, giving you the much more precise answer of 7.0. No data lost. Pretty smart, right?
Okay, now let's talk about explicit conversion. This is what you'll be doing most of the time. This is where you have to step in and direct the show, which is absolutely essential when you're cleaning up data from real-world sources like CSV files or web scraping.
And these 4 functions right here, these are the absolute workhorses of explicit conversion. You've got int for whole numbers, float for your decimals, string for text, and bool for those true-false values. Getting these down is totally fundamental.
But here's a classic trap. And trust me, everybody falls into this at some point. If you try to take a string that has a decimal point in it and convert it directly into an integer using intap, Python's just going to stop you in your tracks. It'll throw a value error because it has no idea what to do with that 0.45 part.
So the solution is this really clever 2-step move. First, you convert the string 123.45 into a float, which the float function handles perfectly. That gives you the number 123.45. Then, once it's a number, you can safely convert that float into an integer. It just drops the decimal part, leaving you with 123. It's a super important technique to remember.
Okay, so converting one value at a time is great and all. But in data science, we're not dealing with just one number. We're dealing with columns that have thousands, maybe even millions of values. So how do we do this at scale?
This is where the pandas library becomes your absolute best friend. It has this incredible method called asType. And with just one simple line of code, like you see here, you can change an entire salary column from text to numbers. Just like that, it's ready for analysis.
And it is the exact same story with NumPy, which is the powerhouse library for all things numerical in Python. If you have a big array of numbers that are accidentally stored as strings, you use the exact same .asType method. It converts the entire array to a consistent numerical type, which is a must-have for most mathematical models.
Now, what's really cool is seeing how this all comes together in a real data cleaning workflow. You're taking raw text data for things like age, height, and gender, and you're just systematically converting each one into a format the machine can understand: integers, floats, and binary numbers. This right here is the heart of data preprocessing.
So to wrap this up, let's just boil it all down into a quick reference guide, a little cheat sheet you can use anytime you're staring down a new, messy data set. These are the big ones. Remember your core functions for single values, know the simple rules for Booleans, where zero and empty things are false, and for any big data set, any data frame, asType is going to be your go-to command.
So really, at the end of the day, mastering type conversion isn't just about ticking a technical skill off a list. It is the fundamental power that lets you take a chaotic mess of raw data and transform it into clean, structured information that can actually give you powerful insights. It's the very first real step you take on the path from just having data to making a discovery.